Hey guys, this is the review for the most recent test that you need to take this weekend. So I'm going to just go ahead and kind of go through this. If you need to pause it so you can copy stuff down, that's fine. But I did want you to have access to it. So like I said, these are just some of the review questions that will be on your test. And you might even see these questions in your review because that's where I pulled them from on MathXL. So the first problem, we've done quadratic formula over and over and over again. So the first thing I'm going to do is I'm going to identify A, B, and C. I'm going to plug that into my quadratic formula. So all that goes into the formula. If you notice that I've made a mistake, please contact me so I can correct it. When you simplify everything, you have double negatives here. Denominator becomes a 2. And then when you simplify what's under the radical, you get square root 141. Now, you cannot simplify the square root of 141. It does not go down any further. So this would be your answer. Now, I do not know if MathXL wants it as 11 plus square root 141 over 2 and 11 minus square root 141 over 2. So pay attention to that, if they'll take it collectively or if they want it separately. The next example that you will see scattered throughout your review on MathXL is this word problem. So if a certain cannon is fired from a height at 9.6 meters above the ground and at a certain angle, the height of the cannonball above the ground, h, in meters, at time t in seconds is found by this given function. Find the time it takes for the cannonball to strike the ground. So we're at 0 meters when it strikes the ground. So 0 equals to negative 4.9 t squared because you're solving for time, so t has to stay. We're going to plug all of that into our quadratic formula. So that would be negative 27.5 plus minus the square root of 27.5 squared minus 4 times negative 4.9 times 9.6, and all of that is over negative 4.9 times 2. So I'm going to have to go down into the next space just a little bit. So I end up with x equals to negative 27.5 plus minus. I do the bottom first. You know how I work these problems out. And then when you do all that math under the radical, you get 944.41. So now what I need to do is I need to figure out which answer is going to produce a positive value, and that will give me my time. So I do need to split this fraction up into 1 plus the radical, and then the other one has the minus a radical in it. So minus that bigger radical. All right, so this answer gives me negative 0.33, but this answer gives me positive 5.9. So it takes 5.9 seconds for that cannonball to hit the ground. In this example right here, we're going to use the square root property. So I get x squared equals to negative 121. When you square root both sides, do not forget the plus minus feature. Plus minus I square roots of 121, since that's a negative 121. So x equals to plus minus 11i. That would be the answer for that particular question. Now, in the next question, it says write the polynomial in standard form, then classify it by its degree and its number of terms. So first thing, we have to write it in order, 9x squared plus 7x minus 6. So that took care of that. Classification, degree-wise. Since your degree is 2, that is called a quadratic. And the number of terms We have 3 terms, which means it is a trinomial. All right. Determine the end behavior of a polynomial function. Well, my biggest exponent term is 11, so this is a positive odd polynomial, which means the endings go opposite directions. So the left end goes down and the right end will rise because it is positive. If it had been a negative odd, the endings would have done the same, or the opposite of what the positive odds do. Now remember, if it's positive even, they both go up. And if it's a negative even, they would both fall. But this is the answer for this particular question, just a quick reminder. Now, I am going to do these 2 questions backwards. I am going to do the one on the right first. It says find the zeros. So I'm going to take each factor, set each factor equal to 0, and then I'm going to solve each factor, and that will give me my zeros. So I have 1, 0 at -1, 1 at +3, and the third one is at +4. So the question on the left does the exact opposite. It gives us the answers, and we have to put it back into the equation form. So it gives me x equals 1, which turns into the factor x minus 1. It gives me x equals -2, which turns in the factor x plus 2. It gives me x equals to -6, which turns into x plus 6. I'm going to FOIL these 2 together. So that gives me x squared plus 2x minus x minus 2, which gives me x squared plus x minus 2. Now I'm going to have to FOIL it with the x plus 6. I'm going to erase this over here because you could have paused the video to get what you needed off of that side. So when I multiply, I'm going to distribute that x squared over here. So that gives me x to the third plus 6x squared. Then I'm going to take my x and do the same thing. So that gives me x squared plus 6x. Then I'm going to take the -2 and distribute it. So that gives me -2x minus 12. And all that will equal to 0. Combine your terms. I can add those together and get 7x squared. I can add these together and get positive 4x and then subtract the 12. And that would be the equation associated with this question. Now, in the next set of questions, we're going to do some synthetic division. To determine whether a given binomial is a factor or not, you're going to do the division and you want the remainder to be a 0. If the remainder is 0, then x plus 5 is a factor of the given polynomial. If the remainder is not 0, then x plus 5 is not a factor. Now remember, I see x plus 5 here, but I need to divide by the opposite of that. And then I'm going to pull my coefficients. I do not need to put any 0 fillers because I do not have any missing terms. So always pay attention for the missing terms. Remember the synthetic division process. Bring the first term down. And then you're going to multiply. That gives me -5. And then you will always add these 2. Multiply again. That gives me -35. When I add, I get -4. And when I multiply, when I add, I do not get 0. So no, x plus 5 is not a factor of that given polynomial. So synthetic division a couple more times. So here we're going to divide by +4. I'm not missing any terms, so I am going to write down all of my coefficients. Bring the first one down, and then you multiply. You add, and then you multiply. I'm sorry, that should be 56. This is 52. You multiply, you get 208, and when you add, you get 217. So what this tells me about this particular problem is that when I take the numerator and divide it by x minus 4, I end up with 2x squared plus 14x plus 52 with a remainder of 217. In the next problem, x to the 5th plus 32, I have a lot of missing terms. I have to fill in a lot of stuff. I need a 0x squared, or x to the 4th. I need a 0x to the 3rd. I need a 0x squared. I need a 0x, and then I have a no x term. So I have a lot of zeros that I have to fill in before I can do my synthetic division. So I'm going to put a -2 out in front, because remember, you always divide by the opposite of what you see. So I have 1, 2, 3, 4 zeros that I had to fill in. Make sure you double check. 1, 2, 3, 4. So I'm going to bring down the first number when I multiply, then I add, multiply and add, multiply, add, multiply, add, multiply, and add. Remember, this number is your remainder. So the quotient, remember, when you write your answer to a synthetic division, it always starts 1 degree less than the original problem. We had an x to the 5th, so I'm going to start my answer with the x to the 4th. So x to the 4th minus 2x to the 3rd plus 4x squared minus 8x plus 16 with a remainder of 0. On the next question, it just says find the number of roots for the following equation. Well, if you recall, the biggest exponent tells you how many roots this equation will have. So we will have 4 roots. That's it. It doesn't ask you to find them. It just says tell the number of roots you should get. Now in the second one, we do have to find all the zeros. So we're looking for 3 x values. So you'll need to pull up your graphing calculator on Desmos. So make sure that you pull up Desmos, you graph this, and you will find that x equals -11 is the one and only place that your graph will cross the x-axis. So when I do my division, I'm going to divide by -11, 1, 15, 55, 121. Now remember, if you pull this number off that graphing calculator, because that's exactly where your graph crosses the x-axis, then you should get 0 as a remainder. If not, something is wrong. Double check your math and double check that x-intercept on your calculator. So we pull down that 1, we multiply. When we add, we get 4. We multiply, we get -44. When we add, we get 11. And then when we multiply, we get -121, which does give us 0. Now, that's my first answer. I need 2 more answers. So I'm going to take this problem, that would be x squared plus 4x plus 11. I know we start with x squared because the original problem had an x to the 3rd, and the answer to that synthetic division is always 1 degree less. So now what I'm going to have to do is, since that does not factor, there are no factors of 11 that would give me 4, I'm going to have to do my quadratic formula. So x equals to -b plus minus b squared minus 4 times a times c, and all of that is over 2 times a. Now, that gives me -4 plus minus over 2. The square root is where you spend the majority of your time. When you add up all of this, you should get -28, which should indicate to you that the final 2 answers are going to be imaginary. So I need to break down the square root of 28. I'm going to come over here and erase this, so I have some room to break down that square root of 28 for you. So I have I square roots of 28 The perfect square factor of 28 would be 4. The non-perfect square would be 7. You can take the square root of 4, but you cannot take the square root of 7. So this becomes negative 4 plus or minus 2i square roots of 7 all over 2. Now, the last thing you need to do, look at these three numbers. If you can reduce them all by the same thing, that's great. If you cannot, then it stays. But I can reduce all of those numbers by 2. So my final answer would be negative 2 plus or minus I square roots of 7. So my final two answers, which will be imaginary because I needed 3 answers total, would be x equals to negative 2 plus I square roots of 7 and x equals to negative 2 minus I square roots of 7. So that should get us through the biggest chunk. Now, the next few examples are some radical examples. Also, we have one of the Pascal's triangle. So for this one, if we're going to use Pascal's triangle to expand this, I need the line in the triangle that's 1, 4, 6, 4, 1. So I'm going to make my pattern like we did in class on Wednesday. I'm going to take my first term, so all the first parentheses get an x. All the last parentheses get a 2. Your exponent is going to decrease for the first term, so 4, 3, 2, 1. It will rise for the second term, so I start here with 1, 2, 3, and 4. And remember, was not supposed to erase that, supposed to highlight. These numbers are always supposed to add up to 4, which they do. So now it's a matter of cleanup. We have x to the 4th for the first term. When I multiply 2 and 4, I get 8, x to the 3rd. When I multiply 6 times 2 squared, that's 6 times 4, which would be 24, x squared. When I multiply 4 times 8, 2 to the 3rd is 8, so 4 times 8 is 32, x. And then my final term would be 16, which is 2 to the 4th. And that would be the expansion of x plus 2 to the 4th power. Now, on the last one, on this particular page, if you multiply these two together, and you can because you can multiply a square root times a square root, you're going to multiply the 3 and the 48 together, and that gives you the square root of 144, and the square root of 144 is 12. So 12 would be the final answer for that product, square root 3 times square root 48. And I have 3 more examples that we're going to go over. When you divide, you remember you can make a big fraction. You can reduce that fraction. That reduces to the square root of 100, and the square root of 100 is just 10. I can do the same thing here. Make that a big fraction. I can reduce everything under that fraction. So 56 divided by 7 is 8. Subtract your exponents. 8 minus 5 is 3. 9 minus 7 is 2. Now I have to break up some of these things because 8 is not a perfect square. X to the 3rd is not a perfect square. So I'm going to have to break these terms up. So 8 is going to break up to 4 times 2 because 4 is the perfect square factor of 8, and I can take the square root of that. 2 is not. Since this number is not evenly divisible by 2, I'm going to split it to x squared times x to the 1st. Since this number is divisible by 2, I'm not going to break that one down. Square root of 4 is 2. This 2 divided by that understood 2 is a 1. This 2 divided by that understood 2 is a 1. And so the only thing that's left under that square root is the 2 and the x. Remember, this exponent has to be smaller than the index that you're working with on the outside. I actually told you a fib. There's one more question after the square root of 20 and the square root of 45. So before we can add those together, we have to simplify them. So square root of 20 breaks down to 4 times 5, 4 being the perfect square, and that gives me 2 square roots of 5. So I broke down the square root of 20 and got 2 square roots of 5. The square root of 45 breaks down to the perfect square factor of 9 and 5. I can take the square root of 9, but I cannot take the square root of 5. And so what I should be thinking is 2 plus 3 square roots of 5 would give me 5 square roots of 5. And that would be my final answer for that one. Now the last one is showing you that you can FOIL with radicals. So I'm going to do 5 times 2, that gives me 10. 5 times 6 square roots of 6 gives me positive 30 square roots of 6. I'm going to go negative 5 square roots of 6 times 2. It's negative 10 square roots of 6. And then here I get negative 30 square roots of 36, because the square root of 6 times the square root of 6 is a square root of 36. Now, I can add these two together because they are like radicals. So 30 minus 10 is 20, and I keep the square root of 6. Your thought should be 30 minus 10 square roots of 6. That's where the 20 comes from. And then this I'm going to have to break down. That's going to be negative 30 times 6, because you can take the square root of 36, and that's negative 180. I can add these two terms together for a grand total of negative 170 plus 20 square roots of 6. If you have 20 square roots of 6 minus 170, it's the same answer. Okay, so if y'all have any questions, please let me know. I just wanted to make sure that everybody had access to all of these review questions, but feel free to contact me with any questions or concerns.